The Finance Applications Part 3. This is our final video on financial applications and formulas. In the previous video, we looked at ordinary annuities, and the one thing that was common to both the future value and present value formulas was we assumed that we knew what the payment was. In this video, we're going to assume that we don't know what the payment is, and we want to determine what the payment is. And essentially, we're going to have two different situations. We're going to have an amortization situation. And amortization is what we call it when we come up with a single payment that will be repeated over and over and over again on a regular frequency, and then that will pay off a loan of some sort. And in the second situation, we'll have a future value in mind that we want to save up for, and we'll find a common payment that we can save, and eventually we'll end up with that future value. So in one case, we're going to start with a present value and pay it down to zero. In the other case, we're going to start with a future value and we're going to pay up to that starting from zero. All right. So let's look at example one. We're asked to find the monthly payment required to amortize a $7,500 loan over 5 years with interest charged at a rate of 9% per year compounded monthly. Let's go to our TVM solver. Again, to use the formulas that you have a separate handout that walks through how to do that. And you're more than welcome to take a look at that. You actually should spend some time looking at it. It will help you understand some of the features of the calculator that we've already talked about better than what you may so far. It's also just some good practice in working with various formulas. But for this video, our focus is going to be on the TVM solver. So here is our TVM solver. The first thing we're asked for is the total number of compounding periods. In this case, we're looking at 5 years with monthly compounding. So we're going to take 5 times 12, since each year will have 12 compounding periods in it, for a total of 60 compounding periods. Our interest rate is 9%, and we can just type in the 9. In this case, we do have a present value. It's our loan of $7,500. Somebody gives us $7,500 now for whatever purpose we have, buying a car maybe, and we owe them that money. Payment, we don't know what that is, so we're going to not worry about that for the moment. We're going to assume that we're going to pay the loan down to zero over the period that we're looking at. So the future value of the loan will be zero. That will be when we don't owe anything more. And since we have monthly compounding and we know we're dealing with ordinary annuities, the rest of the entries for periods per year, compounding periods per year, and whether the payment are at the ending or beginning of periods is all correct. So all we need to do now is go back up to the payment, press the alpha key and the enter key for solve, and the calculator will tell us that our payment on such a loan would be $155.69 a month. All right. Now, there are things called amortization tables where you can go through and look at what happens with principal and interest for every payment. And what you usually find with that is that the last payment ends up being a little bit different than all the preceding payments, and that's because of the rounding. Here we would round this to 69 cents, which means we're actually overpaying just a tiny amount every time. So we'd expect our last payment to be a little less than $155.69 as a result. We can, as we did with the previous problem, we can quit out to our calculating screen, and we can say, okay, we made certain payments, so let's find that payment again. Let's go into apps, choose option 1 for finance apps, and then we'll cursor one to the right and choose that variables menu. All right, and in this case we want the payment. That's what we were just calculating. So I'm going to choose option 4 and press enter. And that will repeat the payment for me. If I want that to be positive, I can simply press negative, second, and the negative sign again for second answer, press enter, and I get the positive 155. But let's assume that we make all the payments at 155.69. So I'm going to type that in. And if you remember, we've made a total of 60 such payments. So let's figure out what the total of our payments is. We've paid a total of $9,341.40. $7,500 was the loan that we owed. So we can subtract 7,500 from that previous answer. And we'll press enter. And we find out that we paid $1,841.40 in interest doing that. All right, let's also take a look at example 2. Here we're asked to find the quarterly payment required to accumulate a sum of $7,500 over 4 years with interest earned at a rate of 3% per year compounded quarterly. So we've decided, for whatever reason, we need $7,500 4 years from now. And we want to figure out how much we could put away 4 times a year, once every quarter, to eventually earn that. So let's go into our TVM solver. And let's enter the appropriate values. So we have 4 years, and we have quarterly compounding, or 4 compounding periods a year. So we're going to have 4 times 4, or a total of 16 compounding periods. Our interest rate is 3. Our present value is 0. We're going to assume that we've saved none of this money so far. We're going to calculate payment, so we'll come back to it. Our future value, that's our accumulated amount. We eventually want to have $7,500 when this is all done. And we have to change the payments per year and compounding periods per year to 4, since this is quarterly compounding. And we'll cursor our way back up here to payment, press alpha, and enter. And we would need to make a payment of $442.94 into our account every quarter, so once every 3 months. And this would actually be at the end of every 3-month period, to eventually have $7,500 at the end of the 4 years. Let's remember that number, $442.94, and quit out to our calculating screen. I'm going to clear our previous work. 442.94. We're going to do that 16 times. Let's see how much money we end up investing. $7,087.04. If we take and subtract that from 7,500, so if we enter 7,500 minus that previous answer, so second and the negative key, or you can just type it in if you want. We'll press enter, and it turns out that we earned $412.96 in interest over that time period, not quite one full payment. And we weren't making a lot of payments, and our interest rate was pretty low over the time period. You could play with this and see what would happen if you doubled the interest rate to 6% and then maybe doubled again to 12%. How would that affect your payment, and how would that affect the amount of interest that you end up earning towards $7,500? As you do increase the interest rate, you should find that your payments go down, and therefore the total amount of interest that you earn over the time period goes up.